What if I told you that the life you're living right now is just one of countless versions playing out across an infinite cosmic tapestry? Picture this: somewhere out there, another version of you made a different choice this morning, took a different path, and is now living a life that's both eerily familiar and wildly different from your own. This isn't the plot of a sci-fi movie. It's one of the most profound implications of multiverse theory, a concept that's shaking the foundations of modern physics and philosophy alike. For centuries, we've wondered if we're alone in the universe. But what if the real question isn't whether other life exists, but how many versions of our universe exist alongside ours? The idea of parallel realities might sound like pure fantasy, but some of the brightest minds in science are treating it as a serious possibility. From the bizarre behavior of subatomic particles to the mind-blowing vastness of cosmic inflation, the clues are piling up that our universe might be just one page in an endless cosmic library. Think about that for a second. Every moment of hesitation, every leap of faith, every road not taken somewhere, those choices are playing out in real time, creating alternate timelines like branches on an ever-growing tree. It's enough to make your head spin, but that's exactly why we're here today. Over the next 30 discoveries, we'll journey through the most astonishing evidence, theories, and implications of the multiverse. You'll learn how quantum mechanics suggests particles exist in multiple states simultaneously, how cosmic inflation could have spawned countless bubble universes, and even how black holes might be gateways to other realities. Whether you're a seasoned science lover or just someone who gazes up at the stars with wonder, these ideas will challenge everything you thought you knew about existence. So buckle up, we're about to venture beyond the edges of known reality, where the rules of physics as we understand them start to bend, twist, and sometimes break entirely. The multiverse isn't just a theory, it's a doorway to the greatest mysteries of existence, and you're about to step through it. Let's start with the idea that cracks open the door to the multiverse, the many worlds interpretation of quantum mechanics. Back in 1957, a young physicist named Hugh Everett proposed something so radical it seemed ripped from the pages of science fiction. He suggested that every time a quantum particle faces a choice like whether to spin left or right, the universe doesn't just pick one outcome. It splits. One version of reality goes left, another goes right, and both unfold simultaneously in parallel worlds. Think of it like a cosmic choose-your-own-adventure book where every possible path is taken at once. This isn't just wild speculation. It's a direct solution to one of quantum mechanics' biggest puzzles. Why do tiny particles seem to exist in multiple states until we observe them? Take Schrödinger's famous cat trapped in a box with a 50-50 chance of survival. Conventional physics says the cat is both alive and dead until we look. But Everett's theory flips the script. The cat isn't in limbo. It's alive in one universe and dead in another, with both realities equally real. The moment the quantum trigger decides the cat's fate, reality branches like a fork in the road, and two versions of you witness different outcomes. Now here's where it gets even stranger. If this theory holds, every decision you've ever made, from what you ate for breakfast to whether you took that job offer, has spawned alternate versions of your life. Somewhere out there, a version of you skipped breakfast today, another one moved to a different country, another became a professional skydiver. The math suggests these aren't just hypotheticals but actual, tangible worlds layered atop our own. Critics argue this is just a clever way to interpret equations, not proof of parallel realities. but recent experiments with quantum particles show behavior that's hard to explain without branching timelines. Particles seem to remember paths they didn't take, as if those choices played out somewhere else. It's as if the universe is whispering that Everett might have been onto something. So what does this mean for you? If the many worlds interpretation is correct, then regret might be the most pointless emotion in existence. Every missed opportunity, every heartbreak, every what-if moment somewhere, another version of you lived it differently. The multiverse isn't just a cosmic curiosity. It's a mirror reflecting every possible version of your life, all equally valid, all unfolding in an infinite symphony of realities. And this is just the first stop on our journey through the multiverse's greatest mysteries. But if quantum branching creates nearby parallel worlds, what about universes so alien they make alternate versions of Earth look tame? Enter cosmic inflation, the theory that our entire universe is just one lonely bubble floating in an endless sea of others. Picture a pot of boiling water, where each rising bubble is a complete cosmos with its own unique physics. Some might have light that moves slower than molasses. Others could have gravity so weak that planets never form. And here's the kicker, these bubbles aren't science fiction. They're a direct prediction of Alan Gough's groundbreaking work in the 1980s. Gough realized that in the first fraction of a second after the Big Bang, space didn't just expand, it exploded outward faster than light itself. This inflation stretched the infant universe like taffy, smoothing it into the vast cosmos we see today. But here's where it gets wild. Inflation might never have stopped completely. Instead, it could still be happening in distant regions, endlessly birthing new bubble universes like ours. Imagine a cosmic version of a bread machine, constantly kneading dough that rises into entirely new loaves, each with a different recipe for reality. Now consider what this means for the laws of physics. We've always assumed gravity, light speed, and other constants were universal rules. But if bubble universes exist, they might only be local ordinances. Some bubbles could have stronger nuclear forces, making stars burn out in seconds. Others might lack dark matter entirely, with galaxies spinning wildly out of control. There could even be bubbles where time flows backward or space has extra dimensions curled up like hidden origami folds. The craziest part, we'll likely never detect these other bubbles directly. The space between them inflates so rapidly that not even light could cross the gap. It's like being trapped in an endless hotel where every room is its own universe, but the hallways stretch to infinity before you can knock on a neighbor's door. Yet despite this, scientists find eerie clues supporting the theory. Our universe's startlingly uniform temperature, the same in all directions, makes perfect sense if inflation ironed out cosmic wrinkles early on. Even the mysterious cold spot in our cosmic microwave background could be a bruise from colliding with another bubble long ago. So next time you gaze at the night sky, remember, those stars might not just be distant suns. They could be the closest thing to a no trespassing sign, marking the edge of our bubble's jurisdiction in a multiverse where the rules change just beyond the horizon. And this is just the second layer of the multiverse mystery. Wait until you hear how black holes might be stitching these bubbles together. Now let's stretch your mind even further. What if everything you see around you, from the stars above to the screen in front of you, isn't truly three-dimensional at all? Imagine our entire universe as nothing more than an incredibly detailed projection, like a movie playing on the surface of an invisible cosmic sphere. This isn't just a wild thought experiment. It's the heart of the holographic principle, a theory so bizarre it makes parallel universes seem almost ordinary. The idea first emerged from scientists studying black holes and string theory. They noticed something astonishing: the information swallowed by a black hole doesn't vanish into oblivion. Instead, it gets smeared across the black hole's event horizon like data encoded on a celestial hard drive. That discovery led to a jaw-dropping possibility. If a black hole's three-dimensional interior can be perfectly described by information stored on its two-dimensional surface, maybe our entire universe works the same way. Picture a hologram sticker, flat to the touch, yet creating the illusion of depth when light hits it just right. Now scale that up to cosmic proportions. The chair you're sitting on, the trees outside, even your own body, might all be projections from a hidden, flat reality where the true rules of existence are written. But here's where it gets even weirder. If our universe is a hologram, then other holographic realities could exist right alongside ours, each with its own unique set of dimensions and physical laws. Some physicists speculate that black holes might not just store data, they could be bridges to these shadow realms. Fall into one, and you might not be crushed into oblivion. Instead, your information could get scrambled and reprojected into a universe where gravity works backward, or where time flows in loops. Of course, skeptics argue this sounds more like philosophy than physics. After all, how could a flat surface encode something as complex as human consciousness or the swirling arms of a galaxy? Yet experiments with powerful lasers have already shown that certain quantum systems behave exactly as the holographic principle predicts, with lower dimensional boundaries governing higher dimensional spaces. It's as if reality itself is whispering that we're all just actors in a play staged on the thinnest possible screen. So the next time you scroll through your phone or watch sunlight filter through the trees, ask yourself, are these experiences truly happening in 3 dimensions, or are we all just characters in a cosmic movie with a real script written somewhere beyond the edges of perception? The holographic principle doesn't just challenge our understanding of space. It forces us to wonder whether reality is merely the surface of something far deeper, stranger, and more magnificent than we've ever dared to dream. And if that's true, what other impossible worlds might be flickering just beyond the projector's edge? There's something unsettling happening at the edge of our observable universe, an enigma so perplexing it challenges everything we thought we knew about cosmic motion. Picture hundreds of galaxy clusters, each weighing as much as a quadrillion suns, all streaming toward the same mysterious point in space like moths drawn to an invisible flame. Astronomers call this dark flow, and it defies all conventional explanations. The universe is supposed to expand uniformly, with galaxies drifting apart like raisins in rising bread dough. So why are these colossal structures racing toward something beyond our cosmic horizon? One daring possibility sends shivers down the spines of physicists. These galaxies might be feeling the gravitational pull of another universe. Think of it like standing on a beach and feeling the tide tug at your feet, except in this case, the tide is an entirely separate reality lurking just beyond the fabric of our own. The idea isn't as far-fetched as it sounds. If bubble universes exist, as inflation theory suggests, they wouldn't just sit idle in some abstract void. Like soap bubbles jostling in a sink, they could nudge against one another, their gravitational fields leaking through the thin walls between them. Our universe might be sliding toward a cosmic neighbor we can't see, like a ship caught in the invisible current of a hidden whirlpool. The evidence comes from meticulous observations of the cosmic microwave background, the afterglow of the Big Bang. Subtle distortions in this ancient light reveal the direction and speed of dark flow, and the numbers don't add up. These galaxies are moving too fast, too uniformly, as if something massive, something outside our universe, is reeling them in. Some calculations suggest the culprit could be a supercluster in another universe, so enormous its gravity warps space across dimensional boundaries. Of course, skeptics have alternative explanations. Maybe dark flow is just a measurement error, or perhaps our understanding of cosmic expansion is incomplete. But here's the tantalizing part. If dark flow is proof of a neighboring universe, it would be the first tangible clue that we're not alone in the multiverse. Not just in the sense of alien life, but in the existence of entire other cosmoses with their own laws, their own histories, their own versions of reality. So the next time you gaze up at the night sky, remember this: the stars might not just be points of light. They could be trail markers on a cosmic highway, hinting at destinations beyond the limits of our imagination. And if dark flow is what we think it is, then the greatest journey in the universe might not be outward but sideways, into realms where the rules of physics as we know them are just one possibility among infinite others. What if the universe isn't just described by mathematics? What if it is mathematics? That's the radical proposition at the heart of Max Tegmark's mathematical universe hypothesis. Imagine peeling back the layers of reality like an onion, past atoms and quarks, past even the fabric of space-time, until you reach the deepest layer of all, pure, abstract mathematical structure. No matter, no energy, just equations humming in the void. According to Tegmark, this isn't some poetic metaphor, it's the literal nature of existence. Every consistent mathematical structure doesn't just describe a possible universe, it is a universe spinning out there in the multiverse's infinite catalog. Take something as simple as the number pi. In our world, it's the ratio of a circle's circumference to its diameter, an endless string of digits with no repeating pattern. But in another mathematically valid universe, pi might be exactly 3, making perfect circles possible. Or imagine a cosmos where geometry follows the jagged rules of fractals, with coastlines that branch infinitely and mountains that look identical whether you're viewing them from space or through a microscope. These aren't just thought experiments. If Tegmark is right, these worlds exist as surely as the one you're experiencing right now, each with its own set of mathematical rules generating physics, chemistry, even conscious beings who perceive their reality as solid and real. The implications are staggering. It means that somewhere there's a universe where gravity behaves like light waves, where time has 7 dimensions, or where black holes sing in harmonic frequencies. There could even be universes so alien that human logic can't begin to describe them, realities built on equations we haven't discovered yet. Tegmark's hypothesis obliterates the line between the possible and the impossible. If the math checks out, the universe checks out. But how could something as intangible as a mathematical equation manifest as a physical world? Think of it like a video game. The worlds you explore in virtual reality aren't made of pixels deep down, they're made of code, invisible instructions that generate every mountain, character, and law of physics in that digital realm. In the same way, our universe might just be the output of a cosmic equation running on a substrate we can't perceive. Even the randomness of quantum mechanics could be the universe's way of processing unresolved calculations, like a computer working through variables in real time. Critics argue this reduces reality to a sterile set of symbols, stripping away the richness of experience. But Tegmark counters that math isn't cold or lifeless, it's the opposite. The fact that a single equation can describe the spiral of a galaxy and the curl of a breaking wave suggests an elegance deeper than materialism or spirituality. It's a universe where beauty and truth are written in the same language, so the next time you balance your budget or measure a shelf, remember, you might not just be doing math. You might be touching the skeletal framework of existence itself, one thread in a tapestry of infinite parallel equations, each weaving a universe unlike any other. And if that's true, then every unsolved theorem, every scribbled equation in a physicist's notebook isn't just an idea, it's a cosmos waiting to be discovered. Einstein once called it spooky action at a distance, the bizarre phenomenon where two entangled particles, separated by light years of empty space, instantly mirror each other's behavior. Tweak an electron's spin here, and its partner flips simultaneously, as if no distance exists between them. This isn't just quantum weirdness, it might be our first tangible clue that particles are whispering to each other across parallel worlds. Picture this, two coins flipping in different galaxies, always landing on matching faces no matter how far apart they're tossed. That's entanglement in action. But here's the twist, what if those coins aren't communicating faster than light? What if they're actually the same coin, existing in multiple realities at once? Some physicists propose that entangled particles aren't separate entities at all, but splintered fragments of a higher dimensional object, like shadows cast by a single shape rotating through unseen dimensions. Imagine a cosmic deck of cards where each card is a universe, and entangled particles are the same corner of the card peeking through multiple layers. Tug that corner in one reality, and it moves in all the others simultaneously. This idea stems from string theory's wildest offshoot, the brane multiverse. In this model, our entire universe might be a three-dimensional brane floating in a higher dimensional space, like a page in a colossal cosmic book. Other branes' parallel universes could hover millimeters away in these hidden dimensions, utterly invisible to us. Entangled particles might be rare points where these branes overlap, their quantum states tethered across realities like threads stitching through fabric. When we measure one particle, we're not just collapsing its state. We might be tugging on a thread that vibrates through the entire multiverse. Experiments are already hinting at this interconnected web. Quantum systems sometimes behave as if they remember paths they never took, like echoes of choices made in alternate realities. In 2008, physicists even proposed testing whether entanglement could arise from particles interacting in parallel worlds, a theory dubbed many worlds entanglement. While still speculative, it's a tantalizing bridge between quantum mechanics and multiverse theories. So the next time you hear about particles defying space and time, consider this: entanglement might not be breaking the rules of our universe. It could be playing by a grander set of rules, ones written across the canvas of the multiverse itself, where every flip, every spin, every quantum whisper is part of a conversation spanning countless realities. And if that's true, then the spookiest action isn't happening at a distance, it's happening everywhere all at once, in ways we're only beginning to fathom. Here's a chilling thought. What if everything you've ever experienced, from the warmth of sunlight to the sound of laughter, wasn't generated by a real, physical universe at all? What if you're just a momentary flicker of self-awareness, a disembodied brain that spontaneously assembled from random quantum noise, hallucinating an entire lifetime in the blink of a cosmic eye? This isn't a plot twist from a dystopian novel. It's the Boltzmann brain paradox, one of the most unsettling ideas to emerge from multiverse theory. The paradox takes its name from Ludwig Boltzmann, a 19th century physicist who grappled with the nature of randomness in an infinite cosmos. If the multiverse truly stretches forever, then even the most improbable events must happen somewhere, including the spontaneous formation of fully conscious minds. Imagine shuffling a deck of cards forever. Eventually, you'll get a perfect shuffle where every card lands in order by sheer chance. Now scale that up to atomic levels. Given enough time and space, random particles could theoretically arrange themselves into a functioning human brain, complete with fabricated memories of a past that never existed. Here's where it gets even stranger. Statistically, in an eternal multiverse, these phantom brains would vastly outnumber real, biologically evolved minds. The odds of you being a Boltzmann brain, a fleeting accident of entropy, are astronomically higher than you being an ordinary person in a stable universe. Every moment you remember, every person you've loved, every sunset you've admired could be an elaborate illusion, conjured up by a mind that didn't exist a second ago and will vanish just as quickly. But wait, doesn't the consistency of our reality disprove this? If we were hallucinating, wouldn't the world glitch like a corrupted video file? Not necessarily. A properly assembled Boltzmann brain would generate a perfectly coherent simulation, complete with memories of checking for inconsistencies and finding none. Even your skepticism right now could be part of the program. It's a paradox so airtight that some physicists consider it a serious crisis for multiverse theories. If the math predicts we're almost certainly hallucinations, but we feel undeniably real, does that mean the math is wrong or that we're fooling ourselves? The implications ripple far beyond physics. If consciousness can emerge from chaos, what does that say about the nature of identity? Are we more than the sum of our particles? And how would we ever prove we're not just cosmic will-o'-the-wisps, blinking in and out of existence before we can even question our own reality? The Boltzmann brain paradox doesn't just challenge our place in the multiverse, it pulls the rug out from under our most basic assumptions about existence itself. Yet there's a curious comfort in this existential vertigo. If we're here questioning the paradox, that very act of questioning might be the best evidence we're not Boltzmann brains after all. Illusory minds wouldn't waste processing power on doubting their own reality. They'd just accept the simulation. So the fact that we're wrestling with these ideas could be the universe's way of whispering, you're more than a random fluctuation. You're part of something real, or at least that's what a Boltzmann brain would want you to think. Imagine living in a world where every direction you look appears utterly flat, like a character trapped in a comic book until one day, a mysterious sphere drifts through your two-dimensional plane, changing size and shape as it passes. To you, this would seem like magic, but to the sphere, you'd just be a Flatlander oblivious to the richness of the third dimension. Now take that same logic and crank it up to 11. String theory, the framework that paints particles as tiny vibrating strings, demands at least 10 dimensions for its equations to work. 6 or 7 of these are curled up so tightly that even atoms seem gargantuan by comparison. But what if other universes don't play by our dimensional rules? Picture a cosmos where extra dimensions aren't hidden at all, where creatures navigate 4 spatial directions as easily as we move forward and backward. In such a universe, gravity might weaken differently with distance, allowing for structures we can't even fathom. Knots in time, bridges through parallel planes, or crystals with fractal edges stretching into unseen directions. A being from this reality could reach through our 3-dimensional space like a hand dipping into a pond, interacting with us in ways that would defy all our intuition. The implications get even wilder when you consider forces. Our universe has 4 fundamental forces: gravity, electromagnetism, and the strong and weak nuclear forces. But a higher dimensional cosmos might have 5, 6 or more, each with bizarre effects. Imagine a force that only acts along a 4th spatial axis, making objects tilt into directions we can't perceive. Or a dimension where light travels in spirals, creating colors beyond our visible spectrum. Civilizations in these realms could build technology that seems like pure sorcery to us. Engines that harness extra-dimensional torque, or communication devices that transmit messages around obstacles by routing signals through higher space. Here's the kicker: we might already have clues about these hidden dimensions. When scientists smash particles at near light speeds in colliders, some energy occasionally goes missing, as if it's leaking into other dimensions. And the perplexing weakness of gravity compared to other forces, that could be because it's not confined to our three-dimensional brain, but diffusing into higher spaces like perfume wafting through a house. So the next time you stare at a shadow on the wall, remember, it's just a two-dimensional slice of a richer, deeper object, and somewhere out there, in a universe with more dimensions than ours, something might be staring back at our world not as a vibrant, multidimensional reality, but as a flattened projection, utterly unaware of the cosmic depths we're all swimming in. Elon Musk once famously claimed the odds we're living in base reality are 1 in billions. It's a staggering statement, but not without merit. At the heart of this provocative idea lies the simulation argument, a hypothesis that reads like a sci-fi thriller, yet comes from the rigorous mind of philosopher Nick Bostrom. Picture an advanced civilization, thousands or millions of years ahead of us, with computing power so vast they could recreate every atom, every thought, every moment of history in perfect detail. Now ask yourself, if such beings exist, wouldn't they run countless simulations of their ancestors? And if so, how can we be sure we're not just one of those simulations, nested inside an endless digital matryoshka doll of realities? Bostrom's argument hinges on a trilemma, three possibilities, at least one of which must be true. First, almost all civilizations like ours go extinct before reaching post-human status capable of running ancestor simulations. Second, if they do survive, they almost never choose to create such simulations. Or third, we're almost certainly living in one right now. The math is unsettling. If even a tiny fraction of advanced civilizations run simulations, the number of artificial minds would dwarf biological ones, making it statistically overwhelming that you and I are among the simulated. But how would such a simulation work? Think of modern video games where entire worlds render only when a player looks at them, a trick called lazy loading. Now scale that up to a universe where quantum uncertainty isn't a fundamental feature of reality, but a clever optimization technique. The simulation wouldn't need to calculate the spin of every electron in Andromeda. It could just generate details on demand when we point our telescopes there. Even the speed of light might be nothing more than a processing limit, ensuring the cosmic computer doesn't overload. Here's where it gets even weirder. If we're in a simulation, there could be glitches, cosmic typos where the programmers cut corners. Some scientists have seriously proposed scanning the universe for pixelation at the Planck scale, or anomalies in high-energy particle collisions that reveal underlying code. Others suggest searching for mathematical patterns in fundamental constants, like finding the signature of an engineer who rounded pi to make calculations easier. Yet the most haunting implication isn't how we detect the simulation, it's what happens if we try to create our own. The moment we successfully simulate a conscious universe, we'd effectively prove that simulated realities are possible, skyrocketing the odds that we're inside one. It's a paradox that could turn every quantum lab into an existential crisis. So where does that leave us? The simulation argument doesn't just blur the line between reality and illusion, it dissolves it entirely. Whether we're lines of code or biological beings, our experiences remain real to us. The love you feel, the stars you admire, the questions you ponder, they matter precisely because they're the fabric of your existence, regardless of where that fabric is woven. And if we are living in some advanced being's hard drive, well, that just makes the universe's greatest mystery not whether we're alone, but who or what is running the simulation. Picture the universe not as a one-time explosion, but as an endless cosmic firework display, each spark igniting a new reality with its own rules, its own history, its own destiny. This is the breathtaking promise of eternal inflation, a theory that reshapes the Big Bang from a singular event into just one note in an infinite symphony of creation. According to this idea, the vacuum of space isn't empty at all. It's a seething quantum foam where microscopic fluctuations can balloon into entire universes in the blink of an eye. Like dandelion seeds drifting on the wind, these baby universes bud off from the fabric of their parent cosmos, inflating at speeds faster than light until they become self-contained realms, forever severed from their origins. Take our own universe as an example. That familiar story of the Big Bang, a hot, dense singularity exploding outward, might actually be a cosmic mirage. What we perceive as the beginning could just be the moment our local bubble of space-time cooled enough for atoms to form, like dew condensing on a window pane. Meanwhile, beyond the edges of our observable universe, the primordial inflation field that birthed us might still be raging, endlessly spawning new universes in an exponential cascade. Some of these newborn realms could last mere microseconds before collapsing. Others might harbor physics so alien that matter never coalesces into stars. And a rare few, like ours, strike the perfect balance to brew galaxies, planets, and life. The numbers are staggering. If eternal inflation is real, then over the past 13.8 billion years, the age of our universe, the multiverse, may have birthed more universes than there are atoms in our cosmic horizon. Each one is a fresh roll of the dice, with randomized physical constants determining whether it becomes a barren wasteland or a lush garden of complexity. Some theorists even suggest black holes could be cosmic midwives, their crushing singularities birthing new universes inside them, with the laws of physics slightly tweaked in each generation. Imagine a vast family tree of universes, each descendant inheriting mutated traits from its parent, some thriving, others fading into oblivion. But here's the most mind-bending implication. If universes can be born from quantum fluctuations, then time itself might be cyclical. Our cosmos could eventually collapse in a big crunch, only to rebound in a new Big Bang. Or vacuum decay, a quantum domino effect, might wipe out our universe's structure, making room for a fresh one to emerge from the ashes. In this view, the multiverse isn't just expanding outward, it's constantly recycling itself, and our Ouroboros of creation and destruction where every ending plants the seed for a new beginning. Critics argue this is untestable metaphysics, not science. Yet subtle fingerprints of eternal inflation might lurk in the cosmic microwave background, the afterglow of our universe's birth. Strange anomalies in this ancient light, like improbable temperature variations, could be bruises from collisions with other bubble universes in the inflationary froth. Others hunt for evidence in the distribution of galaxies, searching for patterns that might reveal our universe's parent, like genetic markers in DNA. So the next time you gaze at the night sky, remember, those stars might be more than distant suns. They could be the embers of a fire that never stops burning, one spark in an endless chain of cosmic rebirths. And if eternal inflation is real, then the question isn't whether other universes exist, it's how many have bloomed and faded since you started reading this sentence. Consider a universe where gravity is slightly stronger, just a fraction of 1%. Stars would burn out in a cosmic blink, collapsing into black holes before planets could form. Now imagine the opposite, gravity a hair weaker, leaving matter too scattered to ever coalesce into galaxies. These aren't hypothetical musings, they're real possibilities that highlight the eerie precision of our universe's constants. From the strength of nuclear forces to the exact balance of dark energy, dozens of fundamental numbers appear fine-tuned to an almost impossible degree, as if some cosmic dials were carefully set to allow galaxies, chemistry, and ultimately, life itself to exist. This razor's-edge precision is what physicists call the fine-tuning problem, and it's one of the most profound puzzles in science. The odds of all these constants aligning by chance are so astronomically low that it's like throwing a dart across the universe and hitting a bullseye the size of a single atom. So how do we explain this? Enter the multiverse. If infinite universes exist with randomized physical laws, then statistically, a handful would inevitably land in the life-permitting sweet spot by sheer probability. We're not special, just lucky, finding ourselves in one of the rare bubbles where conditions allow us to exist and ponder the question in the first place. Yet this elegant solution comes with its own set of mysteries. If most universes are lifeless wastelands, why don't we see any evidence of them? Shouldn't our cosmic neighborhood bear scars from nearby universes with broken physics? Some theorists argue that the very fact we're here to observe the fine-tuning creates a selection bias, what's known as the Anthropic Principle. It's like a lottery winner concluding the odds must have been in their favor because, well, they're holding the winning ticket. But this reasoning feels circular, leaving us wondering if we've explained the mystery or just sidestepped it entirely. Even more unsettling is the question of what or who set the dials in the first place. Could there be a deeper mechanism, some undiscovered law that naturally pushes universes toward life-friendly parameters? String theory offers a tantalizing clue. The multiverse might not be entirely random. Certain constants could be locked into place by the geometry of hidden dimensions, narrowing the range of possible universes. Picture a cosmic lock with countless keyholes. Only a few shapes will turn the tumblers, and those happen to open doors to habitable realms. So where does that leave us? The multiverse may answer the fine-tuning problem, but it also replaces one enigma with another. Instead of wondering why our universe is perfectly calibrated, we're left questioning why a reality with such dazzling diversity exists at all. Perhaps the answer lies not in the numbers themselves, but in the breathtaking fact that we're here to notice them, a fleeting spark of awareness in a cosmos vast enough to contain every possible version of itself. We think of time as an arrow flying relentlessly forward. Eggs crack but never uncrack, memories form but never unform. This one-way street is governed by entropy, the universe's tendency toward disorder. But what if time's arrow isn't universal? Quantum experiments are revealing particles that seem to remember future states, as if the distinction between past and future is blurring at the smallest scales. Take the infamous double-slit experiment, where particles act differently when observed. Recent variations show particles adjusting their behavior based on measurements made after they've already passed through the slits, like a detective changing a crime scene based on evidence collected tomorrow. This quantum retrocausality suggests that on some level the future might influence the past. Now stretch that idea across the multiverse. If time can loop and tangle for a single electron, could entire universes exist where cause and effect run in reverse? Imagine a world where shattered glasses leap from the floor to reassemble on tables, where flames suck heat back into logs, and where people grow younger with each passing day. This isn't just poetic symmetry. Some cosmological models suggest such universes could naturally arise. When the Big Bang birthed our cosmos, it might have also created a mirror universe where time flows backward from that initial singularity. In that realm, our future is their past, and their scientists would perceive our universe as the bizarre, inverted one. The implications would rewrite physics. In a time-reversed cosmos, black holes might spew out matter instead of consuming it, becoming white fountains of creation. Consciousness could work in reverse too, with memories of tomorrow appearing before experiences happen. A resident of such a universe wouldn't notice anything odd to them. Their reality would feel as natural as ours does to us. Critics argue this is mathematical fantasy, pointing out that reverse time would violate thermodynamics. But here's the twist. Entropy might still increase even in a backward-flowing universe. It would just look like decrease to outside observers. Think of watching a movie reel in reverse. The spilled milk seems to leap back into the glass, but the film's entropy scratches, fading still marches forward in the projector's timeline. So if these mirror universes exist, how would we ever detect them? Some theorists propose searching for cosmic rays that behave like they're arriving from the future, or studying particles that seem to carry echoes of events that haven't occurred yet. Others suggest the answer lies in the cosmic microwave background. Subtle asymmetries in this ancient light might reveal where our universe's timeline brushes against its inverted twin. The most profound realization isn't just that time might run backward elsewhere, it's that forward and backward could be illusions of perspective. Like ants crawling on a Möbius strip, we might be trapped in a local perception of time's direction, unaware that the greater multiverse has no preferred arrow at all. And if that's true, then every moment we experience as irreversible might just be one frame in an endless cosmic film, one that some other universe is watching in rewind. Black holes aren't just cosmic vacuum cleaners, they might be cosmic mothers. At the very heart of these gravitational monsters, where space-time curves into infinity and all known physics breaks down, something astonishing could be happening. Instead of matter and energy vanishing into oblivion, they might be reborn, squeezed so tightly that the singularity at a black hole's core becomes the seed of an entirely new universe. Picture a cosmic Russian nesting doll, where every black hole in our universe contains a fledgling cosmos of its own, complete with its own laws of physics, its own stars, and perhaps even its own black holes spawning yet another generation of realities. This mind-bending idea, known as black hole cosmology, suggests that the Big Bang wasn't a one-time event but part of an endless cycle of creation. When matter collapses into a singularity, the extreme conditions might trigger a new inflationary expansion, a baby universe budding off from the fabric of our own, forever hidden behind the event horizon's impenetrable veil. In this scenario, our own universe could be the offspring of a black hole in some higher dimensional parent cosmos, making every galaxy, every planet, and every one of us the product of a celestial rebirth. The implications are staggering. If black holes are universe generators, then the multiverse isn't just a collection of parallel worlds. It's a vast family tree, with each branch representing a new cosmic lineage. Some daughter universes might inherit slight variations in physical constants, leading to realities where gravity is stronger, light moves slower, or chemistry behaves in ways we can't even imagine. Others could be nearly identical to ours, with their own versions of Earth, their own histories, and their own scientists peering into black holes, wondering if they're staring into the eyes of their own creators. But how could we ever test such a wild idea? The event horizon of a black hole is a point of no return, so we can't exactly send a probe inside. However, subtle clues might lurk in the behavior of black holes themselves. Some theories predict that information swallowed by a black hole doesn't vanish but gets imprinted on the new universe's fundamental structure, like a cosmic fingerprint. Others suggest that the gravitational waves rippling through space after black hole collisions could carry echoes of these birthing processes, hidden in the vibrations of space-time itself. Even more tantalizing is the question of our own origins. If black holes spawn universes, then what does that make the Big Bang? Could the explosion that birthed our cosmos have been the death throes of a black hole in another reality? It's a humbling thought that the very fabric of our existence might be stitched together from the remnants of some long-forgotten cosmic giant. And if that's true, then somewhere out there, in the depths of a supermassive black hole, another universe might be taking its first breath, completely unaware that we're here, wondering if we're standing in the shadow of our own creation. What if every moment you stay alive isn't just luck but proof that somewhere out there, another version of you didn't make it? This is the unsettling heart of the quantum suicide thought experiment, a paradox that takes the many worlds interpretation to its most extreme conclusion. Imagine a volunteer steps into a lab and places a gun against their temple, but this isn't an ordinary weapon. It's a quantum trigger rigged to a device that measures the spin of a subatomic particle. If the particle spins left, the gun fires, spin right, and it clicks harmlessly. According to quantum mechanics, the particle exists in both states simultaneously until observed. So when the trigger is pulled, reality splits, one timeline where the volunteer dies and another where they miraculously survive. Here's where it gets eerie. From the volunteer's perspective, no matter how many times they pull the trigger, they'll only ever experience the outcome where the gun doesn't fire. In branches where they die, their consciousness ceases instantly, leaving only the surviving versions to ponder their inexplicable streak of luck. To them, it would feel like immortality, as if fate itself were bending to keep them alive. But in reality, their continued existence is just a statistical inevitability in an infinite multiverse where every possible outcome plays out somewhere. This experiment isn't just a morbid hypothetical, it forces us to confront the nature of consciousness and probability. If the many worlds interpretation is correct, then every life-threatening situation you've ever survived, every near-miss car accident, every dodged illness might not be luck at all. You're simply the version of yourself that keeps landing in the timelines where the dice roll in your favor. The other versions, they vanish into silent branches of the multiverse, their stories cut short while yours continues. Critics argue this is a misuse of quantum theory, reducing profound physics to a philosophical parlor trick. After all, consciousness isn't a magical force that can cheat death. It's an emergent property of brain activity. If a bullet enters your skull in one universe, no amount of branching timelines changes that outcome for you in that reality. But supporters counter that the experiment isn't about literal immortality. It's a lens to examine how subjective experience distorts probability. We remember the timelines where we survive because, well, the alternative leaves no one to remember anything. The most haunting question isn't whether quantum suicide works, it's what this says about the nature of reality itself. If countless versions of us are constantly splitting off into parallel fates, then the version sitting here right now, reading these words, is just one thread in an infinite tapestry of possibilities. And if that's true, then every breath you take isn't just a moment in time. It's a statistical inevitability in a cosmos where every possible outcome must somewhere come to pass. Have you ever been absolutely certain about a memory only to discover undeniable proof that you're wrong? Not just a little off, but convincingly mistaken about details that feel etched in stone. This eerie phenomenon has a name, the Mandela Effect, named after the widespread false memory of Nelson Mandela dying in prison during the 1980s, when in reality, he lived until 2013. It describes those moments when large groups of people share identical incorrect recollections. From the spelling of the children's book series, Berenstain Bears, not Berenstein, to classic movie lines like, "Luke, I am your father," the actual quote is, "No, I am your father." These discrepancies aren't just random mistakes. They're too specific, too consistent across unrelated people to dismiss as simple forgetfulness. So what's really going on? One spine-tingling possibility is that these collective false memories aren't mistakes at all, but residual echoes from alternate timelines. Think of reality as a vast, shimmering tapestry of parallel universes, each vibrating at a slightly different frequency. Occasionally, the theory goes, these timelines might brush against one another, creating momentary ripples where memories bleed through. You could have sworn the Monopoly man wore a monocle because in another version of history he did, and somewhere deep in your consciousness, that memory lingers like a half-remembered dream. The implications are staggering. If the Mandela Effect stems from timeline collisions, then our sense of a stable, singular past might be an illusion. History could be more fluid than we ever imagined, with fragments of alternate versions seeping into our collective awareness. Some researchers even suggest these glitches cluster around emotionally charged events or cultural touchstones, as if the intensity of shared experiences makes the boundaries between realities more porous. Skeptics, of course, have simpler explanations. Human memory is notoriously fallible, prone to distortion and suggestion. The brain doesn't record events like a camera. It reconstructs them on the fly, filling gaps with assumptions and cultural influences. And when these flawed memories align across groups, say, because we all saw the same misquoted movie line in parodies, it creates the illusion of a shared alternate past. But here's where it gets even stranger. Quantum mechanics already allows for particles to exist in multiple states at once. If consciousness arises from quantum processes in the brain, could our minds occasionally tap into parallel versions of reality? Some theorists propose that during moments of déjà vu or intense déjà vécu, the unsettling feeling of reliving an experience down to the smallest detail, we might be brushing against our own alternate timelines, catching glimpses of lives we've lived in other branches of the multiverse. Whether the Mandela Effect is a psychological quirk or evidence of a deeper cosmic truth, one thing is certain: it forces us to question the reliability of memory itself. If our past can shift beneath our feet without warning, what else might be less solid than we think? The answer could rewrite not just our understanding of the mind, but the very fabric of reality. The universe is unimaginably vast, with hundreds of billions of galaxies, each containing hundreds of billions of stars. Given those numbers, the math suggests intelligent life should be everywhere. So why does the cosmos feel so silent? This is the Fermi Paradox, one of science's most haunting questions. But what if the answer isn't about where aliens are, but which universe they're in? Consider this: the same fine-tuning that makes our universe habitable might also act as a cosmic quarantine. Imagine a multiverse where every bubble reality has slightly different physics. In some, gravity crushes atoms before they can form complex molecules. In others, dark energy tears space apart before civilizations can arise. Ours happens to be a Goldilocks universe, not just right for life, but perhaps too right for interstellar neighbors. The very constants that allow us to exist might also conspire to keep us isolated, like an island in an ocean of unreachable shores. Here's where it gets even stranger. Advanced civilizations in other universes might face the same dilemma. Their physics could permit faster than light travel or interdimensional communication, but only within their own cosmic bubble. The walls between realities could be more than theoretical. They might be impenetrable barriers, locking each universe into its own pocket of existence. Even if 1,000 alien empires flourished in parallel dimensions, we'd never hear their signals, never find their artifacts, because the fundamental rules of our reality don't allow for cross-universe handshakes. Some theorists take this further. What if civilizations that do crack the code of multiverse travel inevitably destabilize their home universes? the energy required to pierce the veil between realities might trigger vacuum decay, a catastrophic chain reaction that rewrites the laws of physics in an expanding wave of annihilation. In this dark scenario, the silence isn't just bad luck. It's a cosmic survival mechanism. Universes where civilizations break through to others might blink out of existence, leaving only the isolated ones, like ours, to ponder the silence. But there's a flip side to this loneliness. If we're truly cut off from other universes, it means humanity's story is ours alone to write. No ancient alien libraries waiting to be found, no galactic empires to join or fear. Just an endless frontier of stars and questions, with us as the sole witnesses to its beauty. The multiverse might be teeming with life, but this universe, with its particular laws, its fragile balance, could be our private stage. And that makes every discovery, every moment of curiosity, not just a step toward understanding reality, but a declaration that someone is here to notice it. Dark energy isn't just some mysterious force pushing the universe apart. It might be the cosmic fingerprint of the multiverse itself. Picture a universe where dark energy is slightly stronger, just a fraction more potent than in our own. Instead of gently accelerating expansion over billions of years, space itself would rip apart at the seams, tearing galaxies to shreds before the first stars even ignite. Now imagine the opposite, a universe where dark energy is too weak, unable to counteract gravity's relentless pull. Everything collapses back into a fiery crunch before life ever gets a chance to stir. Our universe, with its Goldilocks perfect balance, seems impossibly fine-tuned, like a cosmic tightrope walker surviving against all odds. This eerie precision raises a tantalizing question. What if dark energy isn't a constant at all, but a variable dial twisted to different settings across the multiverse? In some bubbles, it's cranked up to 11, creating barren wastelands where space expands so fast that matter never gets a chance to clump together. In others, it's dialed down to 0, dooming those realities to an early, crushing demise. Our universe, with its modest, life-permitting dark energy, might be the rare exception in a sea of cosmic catastrophes. Here's where it gets even stranger. Some physicists speculate that dark energy isn't just a random fluke. It could be a shadow of something deeper, a clue etched into the fabric of reality. Imagine the multiverse as a vast ocean, with each universe a bubble rising to the surface. The pressure of the surrounding water, whatever lies beyond our cosmic walls, might subtly shape each bubble's properties, including the strength of dark energy inside it. In this view, our universe's gentle acceleration isn't an accident. It's a signature of where we sit in the multiverse's hidden geography, like a tide mark left by some unseen cosmic shore. The stakes couldn't be higher. If dark energy's value isn't random but tied to a deeper multiverse structure, it changes how we understand our own fate. Right now, our universe is on a one-way trip toward cold, empty expansion, a heat death where galaxies drift apart into eternal darkness. But if dark energy can vary, could it also evolve? Could some universes out there have self-correcting mechanisms, like cosmic thermostats that adjust expansion to keep conditions ripe for life? Critics argue we're weaving stories without evidence, but the math hints at possibilities. Certain string theory models suggest dark energy might decay over time, or even fluctuate in localized patches of space. And if that's true, then the multiverse might not just be a collection of static bubbles, but a living, breathing ecosystem where universes adapt, collide, or even reboot themselves. So the next time you hear about dark energy's mysterious push, remember, it might not just be shaping our universe's destiny. It could be the secret handwriting of the multiverse itself, a single line in an infinite cosmic manuscript waiting to be decoded. And if we ever crack its meaning, we might not just understand where we're headed, but where we truly came from. The universe as we know it might not have begun with a bang, but with a bang up. Picture two colossal sheets of reality, each stretching across dimensions we can't perceive, drifting toward each other in the void. When they collide, the impact doesn't just send shockwaves, it ignites an entire cosmos. This is the startling premise of the Ekpyrotic universe model, where our universe isn't the product of a solitary explosion, but the aftermath of a fender bender between cosmic giants. These colliding sheets aren't made of matter or energy as we understand them. They're called branes, short for membranes, theoretical structures from string theory that could exist in higher dimensional space. Imagine two enormous, floating tablecloths in a fourth spatial dimension, each vibrating with its own unique physics. When they smack together, the energy of that collision doesn't just dissipate. It condenses into matter, radiation, and the very fabric of space-time, birthing a universe like ours in the cosmic equivalent of a head-on collision. Here's where it gets even wilder. If branes can collide once, why not endlessly? The Ekpyrotic model suggests these titanic crashes might be cyclical, with universes forming, expanding, cooling, and eventually being swept clean as the branes pull apart, only to collide again in an eternal dance of destruction and rebirth. Our Big Bang might not have been the first chapter in this story, but just the latest page in an infinite cosmic saga where universes rise and fall like breaths. But how could something as violent as a brane collision result in a universe as orderly as ours? The secret lies in the way energy distributes during impact. Unlike the chaotic singularity of traditional Big Bang models, the Ekpyrotic scenario spreads the collision's energy smoothly across the brane's surface. This could explain why our universe appears so uniform in every direction, without the extreme temperature variations a random explosion might leave behind. It's as if the cosmos was ironed flat by the very force that created it. Critics raise valid questions, of course. If branes keep colliding, where's the evidence of previous universes? Shouldn't the aftermath leave some scars in our cosmic microwave background? Some theorists suggest the answer might lie in gravitational waves, ripples in space-time so subtle we've only just begun detecting them. If future observatories find patterns in these waves that match brane collision predictions, it could be the smoking gun for this extraordinary idea. The most mind-bending implication isn't just how our universe began, it's what else might be out there. If branes exist, they could host entirely separate universes with different physical laws, hovering just millimeters away in a dimension we can't perceive. Civilizations in those realms might be asking the same questions we are, utterly unaware that their cosmic neighbors are separated by an invisible gulf no telescope could ever bridge. So the next time you gaze at the night sky, consider this. Those stars might not just be remnants of an explosion. They could be the echoes of a crash, the glittering aftermath of a collision between worlds beyond worlds, where the birth of reality was less a spark and more a cosmic crunch. And if that's true, then the greatest mystery isn't what came before our universe, it's what's about to collide with it next. There's a moment in every person's life when they stop and wonder, am I the only real thing in this universe? The world outside seems solid, predictable, but quantum physics paints a far stranger picture. At the tiniest scales, particles exist in ghostly superpositions, their properties unresolved until the moment we measure them. This bizarre behavior has led some scientists to propose an idea so radical it redefines reality itself. What if consciousness isn't just observing the universe but actively shaping it? Take the classic double-slit experiment, where particles behave as waves when unobserved, creating interference patterns on a screen. But the instant scientists set up detectors to track which path the particles take, the wave-like behavior collapses. It's as if the particles know they're being watched. This observer effect has fueled wild theories, from the notion that human minds force quantum possibilities to choose a single outcome, to the idea that every conscious being spins off their own private universe where their observations define reality. Here's where things get personal. If consciousness truly influences quantum states, then you watching this right now, might be the anchor of your own branching multiverse. Every glance, every measurement, every decision could be splitting reality into versions where your observations hold sway. In this view, the universe isn't a fixed stage but an ever-shifting hologram, rendered in real time by the act of perception. It's not just that the tree falling in the forest makes no sound. If no one hears it, it might not even fall in any definite way until a conscious mind bears witness. But how could something as intangible as awareness have such power? Some theories suggest consciousness isn't an emergent property of brains, but a fundamental feature of reality itself, like space, time, or gravity. In this framework, the universe isn't just observed by minds, it's composed of them, a vast network of perspectives weaving reality into existence through mutual interaction. Think of it like a cosmic game of telephone, where each observer's experience stitches together a shared consensus of what's real, while alternate possibilities hum just beneath the surface. Critics, of course, dismiss this as metaphysics masquerading as science. They argue that observation in quantum mechanics simply means interaction with any physical system, not a conscious act. A camera or a rock could theoretically collapse a wave function just as well as a human mind. Yet the mystery persists. Why does the universe seem to play by different rules when we're not looking? Why does reality appear to solidify only under the gaze of observation? Perhaps the answer lies not in physics alone, but in the nature of existence itself. If the multiverse is real, then every possible outcome of every quantum event must unfold somewhere. Your consciousness might not be creating new universes so much as navigating them, steering a course through the infinite branches of possibility, with each moment of awareness anchoring you to one thread in the cosmic tapestry. So the next time you catch yourself wondering whether you're truly alone in the universe, consider this. You might not just be a passenger on this cosmic journey. You could be the navigator, the architect, even the engine, with every thought and observation shaping the reality around you in ways we're only beginning to understand. And if that's true, then the greatest discovery of all might not be out there among the stars, but within the very act of looking. From the psychedelic reality bending of Marvel's Doctor Strange to the anarchic interdimensional chaos of Rick and Morty, the multiverse has exploded into pop culture like a supernova. These stories aren't just entertainment, they're training wheels for our imaginations, preparing us for scientific possibilities that might one day upend everything we think we know. But how much of this is grounded in real physics, and how much is pure Hollywood magic? Let's pull back the curtain. Take Everything Everywhere All at Once, a film that turns quantum branching into a heartwarming family drama. The idea that every choice spawns alternate timelines mirrors the many worlds interpretation eerily well, right down to the verse-jumping characters tapping into skills from their parallel selves. But here's where fiction diverges from science. In reality, there's no cosmic iris office connecting these worlds, and no way to download memories from another version of you. Yet the film's emotional core, that every decision matters because it creates new realities, isn't far from what physicists like David Deutsch argue. when they say multiverse theory could redefine free will. Then there's Rick and Morty, which treats alternate dimensions like a fast food menu. Swap out one tiny detail, and boom, you're in a universe where people are chairs or ketchup is sentient. While the show's writers clearly prioritize laughs over lectures, they nail a key scientific concept. In an infinite multiverse, every conceivable scenario must exist somewhere. The absurdity isn't just for kicks. It's a crude but effective illustration of just how wild infinite possibilities truly means. Even kids' movies are getting in on the act. Spider-Man Into the Spider-Verse didn't just dazzle with animation. It introduced a generation to the idea that one hero's canon event might be another's tragic backstory, all coexisting in a web of intertwined realities. The film's portrayal of collider technology smashing dimensions together, pure fiction. But the underlying message, that small changes ripple across realities, echoes theories about quantum decoherence, where particles choose paths that spawn entire new branches of history. So why does this matter? Because science advances faster when culture paves the way. Before Copernicus, the idea of Earth orbiting the Sun seemed ludicrous. Before the Matrix, simulated realities were niche philosophy. Now, as physicists seriously debate bubble universes and holographic realities, pop culture is doing the heavy lifting of making these concepts feel possible. When a kid watching Loki asks if alternate timelines are real, they're not just quoting a TV show. They're priming their brain to one day grapple with cutting-edge cosmology. The best part, these stories aren't just teaching science, they're teaching empathy. If there are infinite versions of you out there, each shaped by different choices and chances, it's harder to see anyone's path as the right one. That's the real magic of the multiverse in pop culture. It doesn't just expand our understanding of reality, it expands our hearts. What if death isn't the end, just a door you never walk through? The quantum immortality hypothesis takes the many worlds interpretation to its most personal extreme, suggesting that your consciousness might be riding a wave of survival across infinite branches of reality. Imagine stepping off a curb and narrowly avoiding a speeding car. In one timeline, you're struck, but in another, you hesitate just long enough to survive. According to this idea, you, the version reading these words, will always find yourself in the realities where the dice roll in your favor, no matter how improbable the odds. This isn't about literal invincibility. It's about the eerie selectivity of experience. Every time you face mortal danger, a near-miss accident, a brush with illness, your consciousness splinters into branches where you live and branches where you don't. But the version of you that continues experiencing reality is by definition the one that survives. The other outcomes still happen, just not to you as you know yourself. It's like flipping a coin 1,000,000 times and always landing on heads. Not because the coin is rigged, but because the tail's outcomes exist in realities you'll never witness. Critics argue this reduces consciousness to a cosmic lottery ticket, with no mechanism to explain why subjective experience would follow certain timelines. After all, if quantum branching creates equally real worlds, why would your awareness cling to the survivable ones? Some theorists propose that consciousness isn't a passive observer, but an active participant in quantum processes, collapsing probabilities into the paths where it can persist. Others suggest it's simply a statistical inevitability. The universes where you're alive to ponder the question are the only ones where the question gets pondered at all. The implications are dizzying. If quantum immortality holds, then from your perspective, you might live to see technologies that extend life indefinitely, simply because timelines where you die young become branches you never experience. Future civilizations could be filled with people who have cheated death not through science, but through the sheer math of probability. Yet this raises a chilling paradox. If consciousness always finds a way to continue, why does anyone remember death happening to others? Shouldn't we all be surrounded by inexplicably lucky individuals? Perhaps the answer lies in the nature of shared reality. Even in a multiverse, certain events like the death of a loved one are so statistically overwhelming that most surviving versions of you still experience loss. Quantum immortality doesn't grant invulnerability. It just means that somewhere in the cosmic tapestry, there's always a thread where you endure, no matter how frayed the others become. So the next time you narrowly avoid disaster, consider this. You might not just be lucky. You might be a testament to the universe's most haunting equation, one where consciousness and survival are forever entangled, and death is just a shadow cast by the timelines you'll never see. Here's a thought experiment that flips our entire perspective on existence. What if the universe isn't fine-tuned for life, but life is simply the inevitable result of a universe that happened to be fine-tuned? This is the essence of the Anthropic Principle, the idea that we observe a life-friendly cosmos, not because it was designed that way, but because we couldn't possibly be here to observe it otherwise. Imagine a vast library where every book contains the laws of a possible universe. Most are gibberish, unreadable jumbles of physics that never allow atoms, stars, or thinkers. But a rare few have just the right syntax for stories to unfold. We're not special for finding a coherent book. We had to find one because the others don't produce readers. But here's where the multiverse cranks this logic up to cosmic scales. If infinite universes exist with randomized laws, then statistically, a handful must land in the habitable sweet spot by sheer probability. The fine-tuning mystery isn't solved, it's redistributed. Instead of asking why our universe is so improbably perfect, we're left wondering why any life-permitting universes exist at all. It's like walking into a casino and seeing someone roll 1,000,000 dice into perfect alphabetical order. The odds seem impossible until you learn there are trillions of unseen gamblers, each rolling endlessly. Sooner or later, someone hits the jackpot. Critics argue this is a philosophical sleight of hand, saying, "We got lucky because someone had to," doesn't explain why the dice exist in the first place. Why should the multiverse contain even a single universe where particles can bind into DNA, or where entropy doesn't instantly erase complexity? Some theorists propose a deeper layer. Perhaps the rules governing the multiverse itself favor the occasional habitable bubble. String theory hints that certain physical constants might be locked into place by the geometry of hidden dimensions, narrowing the range of possible universes. In this view, the multiverse isn't a random lottery, it's a garden where life-friendly conditions are rare but inevitable, like flowers breaking through cracks in concrete. Yet the most haunting implication isn't about physics, it's about meaning. If our existence is just a statistical fluke in an indifferent multiverse, does that make life precious or pointless? The answer might depend on perspective. In one sense, we're impossibly fragile, a fleeting alignment of constants in a cosmos that's mostly hostile. But in another, we're the universe's way of understanding itself, a rare spark of awareness in the infinite dark. Whether that's a happy accident or something more profound remains the greatest question of all. Black holes devour everything that crosses their event horizon, but what if there's a cosmic counterpart that does the exact opposite? Enter white holes, the hypothetical yin to a black hole's yang. While black holes suck in matter with such force that not even light can escape, white holes would theoretically blast energy and particles outward with equal intensity, like a cosmic fire hose that nothing can enter. Picture a black hole running in reverse. Instead of a one-way trip into oblivion, it's a violent eruption of creation, hurling everything inside it back into space. These bizarre objects aren't just science fiction, they emerge as legitimate solutions to Einstein's equations of general relativity, the same math that predicts black holes. But unlike their dark siblings, white holes would be spectacularly unstable. The moment even a single speck of dust tried to cross back into one, the entire structure would collapse. This fragility might explain why we've never observed one, but it hasn't stopped physicists from asking an even wilder question. Could white holes be the birthplaces of entire universes? Think of a black hole in some parent universe where matter and energy vanish beyond the event horizon. Where does it all go? One radical possibility is that it doesn't just compress into a singularity. It gets funneled through a cosmic wormhole and erupts out the other side as a white hole, birthing a brand new spacetime. Our Big Bang could have been the explosive moment when a white hole in some higher dimensional reality spat out the seeds of our cosmos. It's a mind-bending twist on the old saying, one man's trash is another man's treasure. One universe's devoured star could be another's primordial fireball. The implications are staggering. If this theory holds, every black hole in our universe might be growing a baby cosmos inside it, hidden behind the veil of its event horizon. Our own universe could be nested inside another like a Russian doll, with an infinite hierarchy of realities branching outward and inward. Civilizations in those other realms would have no way of knowing we exist, just as we've yet to find proof of our own cosmic parent. But how would we ever test such an extraordinary idea? Some clues might lurk in the cosmic microwave background, the afterglow of the Big Bang. If our universe erupted from a white hole, that violent birth could have left faint patterns in this ancient light, like stretch marks from a cosmic labor. Others suggest that certain anomalies in the distribution of galaxies or the behavior of dark matter might hint at our universe's exotic origins. Of course, skeptics argue that white holes are mathematical curiosities with no basis in observed reality. Yet the same was once said of black holes until we found them lurking in the hearts of galaxies. Whether white holes exist or not, they force us to confront a profound truth. The universe might not just be stranger than we imagine, but stranger than we can imagine. And if even a fraction of these ideas are correct, then the night sky isn't just a window to the stars, it's a mirror reflecting infinite layers of creation, each one born from the death throes of another. If every decision you make fractures reality into countless parallel worlds, then who or what is really in control? The multiverse doesn't just expand the canvas of existence, it throws a wrench into one of humanity's oldest debates. Do we genuinely have free will, or is every choice an illusion? On the surface, branching timelines seem like the ultimate empowerment, a cosmic guarantee that every possible version of your life gets its chance to unfold. But dig deeper and the paradoxes start piling up. If all outcomes happen somewhere, then was any decision ever truly yours to make? Take something as simple as choosing oatmeal over toast for breakfast. In the many worlds interpretation, both options play out: one universe where you savor maple syrup on your oats, another where crumbs from buttered toast scatter across your lap. This feels liberating at first glance, no regret, no road not taken, but here's the rub. If every conceivable choice must manifest in some timeline, then your sense of agency might just be a trick of perspective. You're not steering the ship, you're a passenger on every possible voyage simultaneously, experiencing them one at a time. Philosophers split sharply on this dilemma. Compatibilists argue that free will and determinism can coexist, that even in a multiverse, your choices matter because they define which branch you inhabit. To them, free will isn't about controlling all outcomes, but about authentically making decisions within your own stream of consciousness. It's the difference between being pushed into a river and choosing to swim with the current. But hard determinists counter that if the multiverse contains every possible outcome from the Big Bang onward, then your choices were baked into cosmic history from the start. You are always destined to pick the oatmeal in one world and the toast in another, with no real say in the matter. The stakes get even higher when you consider moral responsibility. If a version of you in another timeline commits a heinous act, does that stain your soul? Are you accountable for paths you didn't take but that you still walked elsewhere? Some ethicists propose that morality in a multiverse shifts from judging actions to judging intentions. The branching happens at the moment of decision, not the outcome. Others insist this is a cop-out, a way to dodge the weight of consequences by offloading them onto alternate selves. Yet there's a third, more unsettling possibility. What if free will isn't about choosing between paths but creating them? Quantum physics suggests that observation collapses probability waves into definite states. Applied to consciousness, this could mean your awareness isn't just riding the multiverse's currents, it's carving them. Every decision becomes a creative act, spinning new realities into existence rather than selecting from pre-written scripts. In this view, the multiverse isn't a predetermined tapestry, but an ongoing collaboration between causality and choice, where you're both the artist and the brushstroke. So where does that leave us? Perhaps the answer lies not in extremes, but in redefining what free will even means in an infinite cosmos. If the multiverse is real, then freedom might not be about controlling every outcome, but embracing the radical truth that every version of you is equally real, and that the power to shape your timeline, even amid infinite others, is the only kind of freedom that ever mattered. Imagine flipping a coin and watching it spin in midair for that brief moment. It exists in a ghostly superposition of both heads and tails. Now imagine that same uncertainty scaled up to the entire universe, where every particle's quantum fuzziness should, in theory, keep reality in a perpetual state of unresolved possibilities. So why don't we see chairs floating in two places at once, or cats simultaneously alive and dead on our kitchen floors? The answer might lie in one of quantum mechanics' most underrated phenomena, decoherence. This isn't just some obscure physics term. It's the reason our world feels solid, predictable, and frustratingly singular despite the multiverse's infinite possibilities humming beneath the surface. Decoherence works like a cosmic eraser, scrubbing away the interference between quantum states until only one outcome remains visible to us. Picture a room full of tuning forks strike one, and the rest start vibrating in sympathy, their energy dissipating into the air until the original note fades into silence. In quantum terms, the moment a particle interacts with its environment, whether it's a photon hitting a detector or an atom bumping into air molecules, its delicate superposition leaks into the surrounding world, collapsing into a single classical state. What we perceive as the real outcome isn't the only possibility. It's just the one that survived this process of quantum Darwinism, where the fittest state gets amplified while others vanish into the background noise of the universe. But here's where things get wild. Some interpretations, like the many worlds view, argue decoherence doesn't actually collapse anything. Instead, it's the ultimate sleight of hand, making other outcomes appear to vanish while they continue thriving in parallel branches of reality. Every time a quantum system decoheres, the universe isn't choosing a single path, it's splitting into countless versions, each inheriting one possible outcome. That coin toss, in one world it lands heads, in another tails, and the reason you only experience one result isn't because the other ceased to exist, but because your consciousness became entangled with a specific branch, blind to the others spreading outward like roots beneath the soil of perception. Critics argue this is just a fancy way of dodging the measurement problem quantum mechanics' lingering question of why observation forces particles to pick a state. If decoherence merely hides parallel worlds instead of destroying them, why can't we detect even a whisper of those other realities? Proponents counter that the math doesn't require them to be detectable. The branches aren't separate universes in some sci-fi portal, since they're more like overlapping layers of a single quantum waveform, forever out of phase with one another. It's less like losing alternate worlds and more like losing the ability to hear one instrument in a symphony. The music still plays, but your ears only catch the dominant melody. The implications ripple far beyond quantum theory. If decoherence is how the multiverse hides in plain sight, then the classical world we experience isn't the default, it's the exception, a narrow slice of an infinitely richer reality. Every decision, every random atomic collision, every photon absorbed by your retina could be spawning new branches of history, all equally real but forever isolated from one another by the relentless entangling of quantum states with their environments. So the next time you marvel at the solidity of the ground beneath your feet, remember, what feels like a single, unwavering reality might just be the quietest corner of a multiverse shouting itself into existence, one decoherent moment at a time. And if that's true, then the greatest magic trick the cosmos ever pulled wasn't making parallel worlds appear, but convincing us they were never there at all. The universe doesn't have to end with a whimper or a bang, it might just bounce. The Big Bounce theory turns cosmic history into an endless loop, where each collapse into a singularity doesn't spell oblivion but rebirth. Picture a cosmic accordion. Space contracts in a fiery big crunch, matter and energy squeezed to unimaginable densities, then rebounds in a fresh Big Bang, spraying new galaxies, stars, and possibilities into existence. It's a vision of time not as a straight line but a circle, with universes rising and falling like breaths. But here's the twist: what if each bounce isn't a perfect reset? What if every cycle tweaks the rules, producing a universe subtly or drastically different from the last? Consider the constants of nature, those seemingly immutable numbers governing gravity, light speed, and quantum behavior. In a cyclic model, these might not be fixed. Each bounce could jostle the cosmic dials, leaving some constants unchanged while others shift. One cycle might spawn a universe where electromagnetism is stronger, forging stars that burn too fast for life. Another could weaken nuclear forces, leaving matter too scattered to clump into planets. Our universe, with its Goldilocks perfect balance, might just be one lucky roll in an endless cosmic dice game. This idea blurs the line between the Big Bounce and the multiverse. Instead of parallel realities existing side by side, they'd unfold sequentially, each iteration a new chapter in an infinite story. History wouldn't repeat, it would remix, with every bounce rewriting the laws of physics like a celestial DJ sampling the universe's greatest hits. Some theorists even suggest black holes could seed these variations. As a universe collapses, the chaotic churn of singularities might reshuffle the deck, ensuring no two bounces are alike. Yet the Big Bounce faces fierce rivals. Eternal inflation, with its bubbling multiverse, argues that universes sprout from quantum foam, not cyclical collapses, and the grim fate of our expanding cosmos hurtling toward heat death, not crunch, seems to defy the bounce's premise. But here's the kicker: dark energy, the mysterious force accelerating expansion, might not be constant. If it decays over eons, gravity could regain dominance, pulling everything back into the next collapse. The very force tearing space apart today might one day turn traitor, setting the stage for a comeback. The most tantalizing clue could lie in the cosmic microwave background. If a previous universe left faint imprints like echoes of a pre-Big Bang structure, they might linger in this ancient light. Some researchers claim to have spotted anomalies, concentric rings, or unusual temperature patterns that could be scars from a prior cycle. Others hunt for gravitational waves from the Big Bang itself, which might carry tremors from events before time as we know it began. So is the universe stuck on repeat? Or is each cycle a fresh experiment? The answer could redefine not just our past, but our future. If the Big Bounce is real, then our destiny isn't cold, empty darkness, it's another dawn, another chance for reality to reinvent itself. And somewhere in that chain of cosmic resurrections, the laws might align just right once more, allowing new eyes to gaze up and wonder. Are we the first to ask these questions, or simply the latest in an infinite line of thinkers reaching for the stars? Time isn't just a river flowing in one direction, it might be an ocean with currents moving every which way. Imagine a universe where time doesn't march forward in a straight line but spirals like a slinky, looping back on itself so that every event happens again and again in an endless cycle. Or picture a reality where time shatters like glass, fracturing into countless shards where moments unfold out of order. If the multiverse contains realms with these bizarre temporal architectures, then so-called time travelers might not be voyagers through history at all, but interdimensional refugees, slipping between realities where time itself is configured differently. Take déjà vu, that uncanny feeling you've lived a moment before. Conventional science explains it as a neurological hiccup, but what if it's something far stranger? In a branching multiverse, there could be realities where events unfold slightly ahead of our own timeline. When your consciousness brushes against a parallel version of yourself living those moments, the overlap might manifest as a fleeting sense of familiarity. Not because you've experienced it in this timeline, but because another you already has. It's less like remembering the future and more like tuning into a cosmic radio station where alternate realities are broadcasting their versions of now. This idea flips traditional time travel on its head. Instead of a single timeline where meddling with the past creates paradoxes, the multiverse offers an elegant solution. Every change spawns a new branch. Want to prevent a historical tragedy? The moment you intervene, you're not rewriting history. You're jumping onto a parallel track where events unfolded differently, while the original tragedy still happened in another universe. This could explain why we've never met visitors from the future. They're not our descendants, but refugees from timelines where their present is our distant past. But what about universes where time isn't linear at all? Some theoretical models allow for closed time-like curves, loops where cause and effect chase their own tails. In these realms, you could theoretically meet your future self returning to warn you about events that haven't happened yet, not because they're inevitable, but because time is a Möbius strip with no true beginning or end. Civilizations in such universes might perceive history as a tapestry to be navigated rather than a story to be lived, with time travelers simply moving through folded layers of reality like ants crawling through the pages of a book. The most mind-bending possibility, universes where time is a fractal, not a line or circle, but an infinitely repeating pattern where every moment contains smaller versions of itself. In these realms, a single second could harbor entire lifetimes, nested like dreams within dreams. A traveler stepping into such a cosmos might experience centuries passing in what feels like an instant, or find themselves trapped in a single heartbeat stretched into eternity. Critics argue these ideas are untestable fantasies, but subtle clues might lurk in quantum experiments. Particles entangled across time, not just space, have shown behavior that defies classical causality, as if they're responding to events that haven't occurred yet. And if consciousness itself arises from quantum processes, Could our minds occasionally slip gears, catching glimpses of timelines where clocks tick to different rhythms? So the next time you feel out of sync with the world, consider this. You might not be late or early. You could be momentarily aligned with a universe where time dances to a beat you'll never hear again, a fleeting harmony in the multiverse's endless symphony of now. What makes you in a multiverse where countless versions of yourself are living out every possible choice? The moment you wake up, a version of you hits snooze. When you pick coffee over tea, another you savors the bergamot steam of Earl Grey. In a cosmos where every decision branches reality, the very notion of identity starts to unravel like a thread pulled from a cosmic sweater. If all these versions are equally real, then the self you cling to might be less a singular entity and more a fleeting snapshot, one frame in an infinite film strip of possibilities. Consider the most mundane moment of your day, tying your shoes, maybe. In one universe, you opt for the double knot. In another, you trip on a loose lace. Both experiences feel equally real to the versions of you living them. This raises a haunting question. If consciousness is just the experience of moving through one branch of the multiverse, then what separates your awareness from the trillions of other yous out there? Philosophers call this the problem of personal identity, and it's been debated for centuries. But the multiverse doesn't just add new layers to the puzzle, it shatters the box entirely. Some theorists propose that identity isn't anchored in memory or continuity, but in something far stranger, quantum entanglement. Just as particles can be linked across space, your consciousness might be entangled with your alternate selves, creating a loose web of you-ness that stretches across realities. Think of it like a choir where every singer is you, each hitting a slightly different note. The melody isn't coming from any single voice, but from the interplay of all of them. In this view, the real you isn't one version, it's the sum of every possible version, resonating in ways we can't yet measure. But here's where it gets even more unsettling. If identity is fluid across the multiverse, then death might not be the end we fear. When one version of you dies, countless others live on, each carrying the same essential thread of consciousness forward. This isn't reincarnation, it's more like a cosmic game of hot potato, where the self is constantly passed between branches of reality. The version reading these words will never experience death, because death is always someone else's timeline. It's a paradox that turns mortality inside out, suggesting that from your own perspective, you might always be the version that survives. Critics argue this reduces identity to a statistical illusion, a trick of probability in an indifferent cosmos. Yet there's a strange comfort in this multiplicity. If every regret, every missed opportunity, every heartbreak is being lived out somewhere by another you, then the weight of what if starts to lift. The multiverse doesn't erase your choices, it sanctifies them all, granting each path equal validity. You're not defined by the road you took, but by the vast network of roads you could have taken, each one a different expression of the same fundamental spark. So the next time you stare into a mirror, remember, the face looking back isn't just a person. It's a probability wave, a momentary convergence of trillions of possible lives, all whispering the same defiant truth, that in a cosmos of infinite versions, there's still only one now, and it's yours to shape. How do you test something that, by its very nature, might exist beyond the edges of observable reality? The hunt for evidence of the multiverse isn't just a scientific challenge. It's a cosmic detective story where the clues are written in quantum probabilities and the faintest whispers of radiation from the dawn of time. On one side of the debate, skeptics argue that if other universes are truly separate realms with their own physics, they should be forever hidden from us, their existence more philosophy than science. But a growing number of researchers are turning that assumption on its head, asking, what if the multiverse leaves fingerprints on our universe, subtle imprints we've been overlooking for decades? Take the quantum realm, where particles behave in ways that defy classical logic. In experiments like the double-slit test, particles seem to sample multiple paths simultaneously, as if probing alternate realities before choosing one. Some interpretations suggest this isn't just metaphorical. These particles might literally be interacting with their counterparts in parallel worlds. Even more tantalizing are quantum entanglement experiments, where particles remain mysteriously linked across vast distances. Could this spooky connection be a thread stretching between universes, a fleeting handshake between realities? A handful of physicists are now designing lab tests to probe this very idea, using ultra-precise measurements to hunt for anomalies where particles appear to remember states they never experienced. In our timeline echoes, perhaps, of choices made in neighboring branches of the multiverse. Then there's the cosmic microwave background, the afterglow of the Big Bang that paints the sky in faint microwaves. Scientists have long studied this ancient light for clues about our universe's origins, but some are now searching for something far stranger, bruises from collisions with other bubble universes. If our cosmos is one of many in a frothing multiverse sea, it's possible we've bumped into neighbors, leaving behind telltale patterns like concentric rings or unexplained cold spots in the radiation. One such anomaly, dubbed the cold spot, has sparked fierce debate. Stretching over 1 billion light-years, this region is curiously devoid of galaxies and far colder than standard models predict. Could it be the scar of a long-ago collision with another universe? Critics argue it's just a statistical fluke, but proponents counter that its sheer size and peculiar structure align eerily well with multiverse predictions. But the boldest attempts to test the multiverse might lie in the realm of mathematics. If the laws of physics in our universe are just one possible configuration among infinite others, then certain fundamental constants like the strength of gravity or the mass of electrons should cluster around life, permitting values in a predictable way. Researchers are now scouring the cosmos for signs of this statistical fine-tuning, asking whether the numbers we observe are too perfectly balanced to be random. It's like finding a safe cracked open to just the right combination, not proof of a locksmith, but a hint that someone or something has been tinkering with the dials. Of course, the greatest obstacle isn't just finding evidence, it's distinguishing it from noise. In a cosmos as vast and ancient as ours, anomalies are inevitable. The real test will be whether multiple lines of inquiry, quantum, cosmological, mathematical, converge on the same astonishing conclusion. And if they do, we might not just be uncovering the existence of other universes, but rewriting the very definition of reality itself. The multiverse could be the ultimate cosmic hide-and-seek champion, but science has a way of shining light in the darkest corners, even those hiding in plain sight. Imagine standing at a crossroads where every path you don't take is still traveled by another version of you. In a multiverse where every choice branches into infinite realities, the stakes of morality seem to both vanish and amplify at once. If every possible outcome unfolds somewhere, does it matter what this version of you decides? Or does the sheer scale of branching timelines make each decision more significant, knowing that somewhere a version of you will live with every consequence? This isn't just philosophical navel-gazing, it's a seismic shift in how we understand accountability, regret, and the weight of our actions. On one hand, the multiverse could be seen as the ultimate moral loophole. Why agonize over a mistake when some other you got it right? Why fret over a hurtful word when another timeline exists where you held your tongue? This line of thinking risks reducing ethics to a cosmic shrug, a belief that no action is truly final because every alternative plays out elsewhere. It's like a child smashing a vase, comforted by the thought that in another room the vase remains untouched. But here's the flaw in that logic: you don't get to experience those other rooms. The version of you reading this is stuck with the consequences of this timeline's choices, and so is everyone around you. Yet there's a counter-argument that's even more compelling. If every decision spawns universes where you're kind or cruel, brave or cowardly, then your actions aren't diluted, they're multiplied. Every act of compassion creates a world where someone was spared suffering. Every lie you tell spawns a reality where trust was broken. The multiverse doesn't erase responsibility. It distributes it infinitely, making you the architect of countless lives, not just your own. Think of it like planting a forest instead of a single tree. You'll never see most of the saplings, but that doesn't make each seed any less vital. This raises a haunting question about intent. If morality is tied to outcomes, how do we judge choices in a multiverse where all outcomes occur? A philanthropist who donates a fortune and a miser who hoards it both create branches where their opposites exist. Does that make virtue meaningless? Not necessarily. Philosophers like Derek Parfit argue that what matters isn't just the result, but the principle behind a decision. In a multiverse, your intentions become the one constant across all branches, the fingerprint of who you are, regardless of which version of events unfolds. The implications ripple into justice and punishment. If a criminal's actions spawn universes where victims suffer, does retribution in one timeline achieve anything? Multiverse ethics might shift focus from punitive justice to prevention, designing systems that minimize the creation of harmful branches in the first place. It's the difference between slamming a cell door and building a society where fewer hands ever reach for the lock. But here's the most profound twist: the multiverse could redefine how we view regret. Normally, remorse stems from the belief that things could have been different. But if every possibility plays out somewhere, then regret isn't about changing the past. It's about aligning your present self with the values you want to propagate across realities. That missed job opportunity, another you took it. The relationship you ruined, somewhere you saved it. The power lies in choosing which of those versions feels most true to who you aspire to be now. Ultimately, the multiverse doesn't simplify morality, it deepens it. Far from a free pass, it's a mirror reflecting the fractal consequences of every thought, word, and deed. Whether that's liberating or terrifying depends on one thing: which branches you decide to water with your attention, your intention, and your courage to live as if this version of reality, the one you're inhabiting right now, is the one that matters most. From quantum splits to cosmic bubbles, the multiverse doesn't just expand our reality, it shatters the very framework of how we perceive existence. Think about that feeling when you're absolutely certain you left your keys on the counter, only to find them dangling from the door. Now scale that uncertainty up to cosmic proportions, where every misplaced moment might actually be a collision with another timeline. These 30 discoveries, whether proven or purely theoretical, aren't just science. They're invitations to wonder, to question whether the solid ground beneath our feet is as unshakable as it seems. The beauty of multiverse theories isn't just in their audacity, but in how they reframe the mundane. That déjà vu you brushed off as a brain glitch, it could be a fleeting connection with a version of you who did take that left turn instead of a right, who chose a different college, who fell in love with someone else. The multiverse turns life's what-ifs from regrets into alternate realities, each unfolding with the same weight and validity as the one you're living now. It's a concept so liberating it borders on existential therapy, because somewhere out there, every road not taken is still being traveled. But let's be clear, this isn't about escapism. The multiverse's true gift is how it sharpens our appreciation for this reality, the one you're experiencing right now. In a cosmos teeming with infinite possibilities, the version of you reading these words is the culmination of every choice, every chance encounter, every quantum fluctuation that lined up just so. That's not just luck, it's a statistical miracle. And if there's one takeaway from this journey through parallel worlds and bubbling universes, it's this: curiosity is our compass. Every great discovery began as a what if, from Galileo's telescope to Everett's equations. So keep questioning, keep staring at the night sky, and wondering what's beyond the edges of the visible. The next groundbreaking revelation might not come from a lab or a telescope. It could strike you in the shower, or during a late-night conversation, or in the quiet moment when you let yourself imagine, what if there's more? The multiverse isn't just a theory. It's a mindset, a reminder that reality is wilder, messier, and more magnificent than we've dared to believe. And if that doesn't make you want to hit like, subscribe, and dive into the comments to debate your favorite multiverse theory, well, somewhere out there, another version of you just did.